Good morning, everybody. Welcome to the last day of reInvent. I'm glad so many of you made the maybe sometimes tough decision to get out of bed and come here this morning. So thank you for coming here today to talk about the relational database service and take a deeper dive under the covers of what RDS has to offer. My name is Scott Ward. I'm a solution architect at AWS. I work on the partner team based out of Seattle. And I'm going to be joined here throughout the day by Katie Singh, who is also a solution architect on the partner team and based out of San Francisco. Quick poll from the audience. Who here today is running RDS, using RDS? Okay. Who here today is running a relational database but on EC2? Okay. And then who's looking to migrate to RDS, whether you're on EC2 or not on EC2 in like the next 12 months? Okay, cool. I think we've got some content in this presentation that's going to apply to all three of those scenarios to kind of help you better understand what RDS can do and some of the ways that you can leverage it and use RDS as a service. We will leave some time for Q&A here today, and if we burn through that time, we'll happily stand down here and continue to answer further questions at the end of the session. So this is a deep dive, so we don't need to spend a lot of time on the value prop of RDS, but just very quickly, there's no infrastructure management with RDS. We take care of ordering and managing the infrastructure for that. RDS is very cost effective because it runs for the database instance with a pay-as-you-go model, and you only pay for the amount of storage that you actually provision. If you're using third-party applications or if you've built your own custom applications that are using a relational database, there's a very good chance that they will continue to work against a database running on RDS. You get instant provisioning with RDS, so when you want a new database with a few clicks of a button or a command line call, you have a database up and running and ready for you to log into in just a few minutes. And you can scale up and scale down with RDS. You can resize your database instance to get a appropriate configuration of CPU and memory. And you don't have to worry about going and finding more infrastructure to support those scaling efforts. Now, RDS is a managed service, so there are some trade-offs that go with that managed service. It's got a fully managed host and operating system, so the good thing is you don't have to burn operational effort to actually manage those components. But what it means is that you don't get access to that host operating system. We control that access. So you're going to have some limited ability to maybe modify configuration settings that you would normally go to the operating system and modify yourself. And that may mean that there's some functions or key functionality in the database that maybe isn't available to you. We're working to bridge those gaps still as a service, but pay attention to those and make sure you look at those if you're just moving to RDS. And then the storage is also fully managed with RDS. Once again, you don't have the operational burden of having to deal with monitoring and managing the storage. But because it's fully managed, there's some limits. If you're using Aurora, you get 64 terabytes of storage, pretty good, good amount. With Microsoft SQL Server, you can have up to 4 terabytes of storage. And with the remaining engines, you can have up to 6 terabytes of storage. So what that means is that growing your database is a process. You have to make some decisions about how much storage you're going to provision. And then you have to make some decisions about when you're going to provision more storage. And if you get to the end and you've used up all the storage available, you have to make some more decisions about, am I going to delete data? Am I going to archive data? Do I need to come up with a sharding strategy in order to create another database and continue to have enough storage available to support my application? This is a view of all the RDS engines that are out there today. So on the commercial side, we have Oracle and Microsoft SQL Server, open source, MySQL, Postgres, and MariaDB. And then in the cloud native category, we have Amazon Aurora, which is supporting MySQL, and now as of Wednesday, the Postgres version of Aurora as well. Who here is like really excited to get their hands on the Postgres side? Yeah. Having done this talk several times throughout the year, like that is a very common question we got from customers. It backs up a lot of what Andy said, so very excited to see what people can do with that when they get their hands on it. So security is a top priority at AWS, and we take a lot of pride and we make it really job zero to ensure that our customers are operating in as safe and secure an environment as possible. And so with that in mind, there's a lot of different things you can do security-wise when it comes to RDS to make sure that you're operating with the right security profile for you. It starts out with a networking that's tied to your database. So as many of you know, we have a virtual private cloud. And when you launch an RDS instance, that instance launches inside a virtual private cloud. And with a virtual private cloud, you can define your own private network address space inside the AWS cloud. You can also carve that up even further into different subnets across different availability zones. So when you've got your database up and running and it's running inside your virtual private cloud, there's lots of different ways that you can manage connectivity and control access into your database. You have AWS Direct Connect, which will allow you to connect your on-premise data center with an AWS region for a high-speed throughput. You can create a VPN connection to have a secure tunnel between your virtual private cloud and your data center or your corporate offices. You can peer multiple VPCs together, either within an AWS account or across different accounts. So if you've got different databases or different applications in other VPCs, you can peer them with a VPC that's maybe hosting an RDS instance and still be able to access them. You have routing rules where you can define and decide how traffic's routed in your VPC. And you can attach an internet gateway to it to actually allow your database to be able to reach the public internet if it needs to. Building on that and going a step lower, we have security groups around your databases. So this is a virtual firewall around your database. It's very similar to what we have in EC2. And it gives you the ability to define inbound and outbound traffic rules as far as what is allowed into your database and what is allowed out. And you can define that at the protocol, the port, and the source level. And with the source level, you have a fair amount of flexibility. You can define a single IP address, you can define a range of IP addresses, or you could actually define another security group as the source. So if you're running a multi-tiered architecture with the database as part of that, you can actually define the source as a security group of the tier above your database that actually needs to talk to your database. And so it allows you to ensure that the components that need to talk to the database can, but that other components or other users can't circumnavigate your security rules as far as how you actually want your database to be accessed. AWS offers identity and access management as a service to control access and permissions within your AWS account against the AWS services you're using. And RDS is one of those services you can certainly use IAM against. One of the key things to call out here, though, is that IAM doesn't control who can log in to your database. You still need to focus on using the grants functionality that exists within your database engine to define users and their passwords and what access those users or the applications have within your database. Identity and access management is going to control what you can do against the actual RDS service. So defining who can create a database, who can modify the configuration of a database as far as the service goes, or delete a database from the RDS service. And one of the cool things with that is that besides monitoring, controlling those types of permissions, if you're using tags on your RDS instance, you can actually define access policies that go down to the tag level. So if you want to say that a support person can only maybe modify development databases versus production databases, you can actually go that fine-grained of your policies around how you use and how people access the RDS service in your account. One of the reasons that people are so concerned or focused on security when it comes to running on AWS is that they have compliance needs that they need to meet. So we have lots of different customers across the enterprise, the public sector, and the startup space who are operating in industries that require that they meet certain requirements in order to be certified as running, being allowed to run for that particular industry. So what AWS has done is we've gone and we've worked with these third-party organizations that you see here on the slide, and we work with them to help them understand the RDS service and make sure that it is running and meets or even potentially exceeds the requirements they have around how the service needs to be operated and how it needs to be secured against their requirements. And so what that means is that you as a customer have the ability to run your applications on top of RDS and achieve a compliance certification. It doesn't mean that you don't have any responsibilities, though. Your security professionals, they don't have to worry about the infrastructure and the RDS service, but they still need to focus their time on your applications and making sure that they're still compliant and they meet the requirements of the organization that you're working with. And you're then able to take the third-party attestations that we can provide around how RDS is meeting the requirements of a particular compliance organization. You can marry that up with your audit findings from your application and have a complete view to show that you are fully compliant with the industry or the organization that you're operating against. This is a view of what we have for compliance for each of the database engines today, with the newest one being Aurora having HIPAA BAA, and PostgreSQL having HIPAA BAA that was announced on Tuesday. One clarification here, the Aurora one currently only applies to the MySQL compatible Aurora. It does not apply to the Postgres Aurora yet. And we're working to bridge the gap with all these engines to help grow this list of compliance bodies that all the engines cover. So over time, you should expect to see this list to grow. Some of these compliance organizations have requirements around protection and encryption of data. And some of them say that you actually have to have your data encrypted in transit. So with RDS, you can actually enable SSL for all the RDS engines to ensure that you have your data encrypted coming into and out of the database to help ensure that you're meeting compliance requirements, whether they be internal or external, to ensure that your data is protected while it's in transit. Another common thing that we see both for internal and external compliance requirements is the need to have data protected and encrypted at rest. So in general, whenever possible at AWS, we recommend that customers encrypt their data wherever they can to help increase and secure their data. And RDS provides you a couple different ways that you can actually go through and implement this protection. If you're using Oracle or SQL Server and you want to use or are using transparent data encryption, you can actually take and implement that functionality on an RDS database. On the Oracle side, you get the extra ability to actually take and store your keys in a cloud HSM module as opposed to just sitting there on the database server. So if you have some requirements or would like to use an HSM as part of your implementation, you can do that with the Oracle implementation. Then for all the engines that RDS supports, you can also implement at-rest encryption using the AWS Key Management Service. So the Key Management Service is an AWS managed service that takes care of all of the scalability, durability, reliability, key rotation, key deletion, key creation that you might expect from a normal key management service. And it allows you to focus on building your applications and integrating with the database without having to invest all the operational overhead and design of actually creating your own key management service. It gives you protection in RDS of the underlying storage that's holding your database or data. It also actually provides protection for the automated backups that RDS gives you, for the read replicas that you can implement with RDS, and for the snapshots that you might create against your database. Those will also all be encrypted. KMS uses industry standard AES 256-bit encryption. And turning on and enabling encryption within RDS using KMS is very straightforward. When you're in the management console, there's one dropdown that's enable encryption. You choose yes or no. If you choose yes and you do nothing else, the RDS service will create a service key in your account with key management service, and that key is tied and owned by your account. It is not, does not live in another AWS account. It's not owned by somebody else. It is tied to your account, and you have full ownership of it. That key is then used to vend up data keys that are used to encrypt and protect your databases, and each database would get its own data key. So each database would be running with its own encryption key. When you go in and you launch a database instance, here's what happens is the RDS service is going to stand up and create the actual database instance. It's going to see that you've enabled key management and encryption. It's going to reach out to the KMS service and say, hey, I'd like to use this key. KMS is going to verify that that database actually has permission to use that master key. When it verifies that and it's all good, it will then back a data key to the RDS service. It will store that key in memory, the database instance, and it will then use that key to encrypt and decrypt your data as you are using the database. An important thing to call out here is that I talked about the service key that you get in KMS. If you want to actually use a different key, you can actually either use KMS to create your own master key, Or if you have a key that you've been using, you can actually import that key into KMS. And you can actually choose to use those keys instead of the service key if you'd like to when you're encrypting your database. So I talked about how it is when you actually enable encryption. This is a screenshot of the management console in the upper right. You can see there's just that drop down of the yes option for enabling encryption. The default there, once again, that AWS/RDS, that's the service-specific key. Or you can enter the Amazon resource name of a different key that you'd like to use that's in your account for encryption. It's also very straightforward to actually enable this at the command line if you're doing some automation around how you create your databases. So there's one extra parameter called storage encrypted. That one will use the default service key. And if you want to use a specific key, you use the storage encrypted option along with the key ID of the key that you'd like to use from KMS. So when you're using RDS and KMS together, there's a couple of hints that I'd like to make sure you're aware of. You can only encrypt when you actually create a new database. So if the database is already up and running, you can't actually just turn encryption on. And once the database is up and running and you have encryption turned on, you can't turn encryption off. Your master and your read replica must be encrypted, and the RDS service actually takes care of that for you. So if you've already encrypted your master database and you go and create another read replica, the service will automatically enable encryption for that read replica as well. If you have any unencrypted snapshots sitting around, you can actually use them to create encrypted databases. So if you have an Aurora snapshot that's unencrypted, when you use that snapshot to create a new database cluster, there's actually now an option to choose that you want that database encrypted, and you can provide the right key that you want to use, and you now have an encrypted Aurora database. If you have a snapshot that's unencrypted for any of the other engines, you can actually take that snapshot, use the copy snapshot functionality, and during that copy process, you can actually choose that you want to have encryption for that new snapshot, choose the key you want to use, and then you can take that new snapshot to actually launch a new database instance, and you now have an encrypted database running as well. You currently can't take a MySQL encrypted snapshot and use it to create an Aurora instance, and you can't use an Aurora encrypted snapshot to create a MySQL instance in RDS. And you can't take any encrypted snapshots and copy them to a different AWS region right now. And you can't do any read replica in other regions if you're using an encrypted database at this point. That's a very common ask from our customers to be able to solve. The product teams, I'm sure, are working on that and trying to find the right way to make that possible. With that, I'd like to hand it over to KD for just a little bit, and I'll be back a little later.
Thank you, Scott. So monitoring your database to see how it's performing, to track some key metrics, to know that these key metrics are within bound, to get notified if some of these metrics get out of bound, and hopefully to automate if something bad happens because these metrics are out of bound, are all critical parts of managing a database. These metrics are also important in Aurora in RDS for scaling operations as well. So let's look at some of the metrics and monitoring related features that RDS offers to you. For anyone that is using RDS, we offer to you around 15 to 18 different metrics. The number of metrics depends on the database instance size that you're using. RDS passes all the information required for these metrics to the Amazon CloudWatch service. And once it's with CloudWatch, you are able to review these metrics from the monitoring tab within RDS console, from within the CloudWatch console itself, or through CloudWatch APIs. You get these metrics at 1-minute intervals. You get these metrics in a nice graphical format. You can see single graphs, multiple graphs, or you can use the CloudWatch APIs to bring all this data into your own logging and monitoring tools. When you get these metrics, you also have the ability to set up CloudWatch alarms. What that means is you set up thresholds on these metrics that are meaningful to you. If the threshold is exceeded because of any reason, you will get notified, and you can use services like Amazon SNS to take automated actions in case the threshold is exceeded as well. When it comes to monitoring your databases, there might be a lot of metrics at the host and operating system level that you might want to track and monitor. in RDS, you don't have the ability to log into the host. You don't have access to the host operating system as well. So to provide you insights related to the host and the host operating system, we offer enhanced monitoring. Enhanced monitoring provides you about 50 additional metrics that you can track. They are also provided to you via CloudWatch. You can choose the latency at which these enhanced monitoring metrics are provided to you. Default is 60 seconds, but you can make it as small as 1 second if you want. With enhanced monitoring, some of the things that you're able to get to are things like free memory, used memory, amount of file system that we have already ended up using as well. So you might be wondering, what's the difference between the basic monitoring, standard monitoring, and enhanced monitoring? Why are they different? To provide to you the standard monitoring metrics, hypervisor is used. Whatever the hypervisor is able to see is whatever is offered to you via the standard monitoring. But hypervisor is not able to get to all the information in the host and the host operating system. It has a limited functionality. So to provide enhanced monitoring metrics, we actually run a lightweight agent on the host itself, the host which is hosting your RDS instance. And this agent is able to collect all the information and provide it to enhanced monitoring, which we provided to you. Along with the Postgres SQL edition of Aurora, we are also announcing a new monitoring feature within RDS, which is called Performance Insights. The goal of Performance Insights is to provide customers with an intuitive graphical interface that helps them determine where the performance bottleneck lie and where they should take some action. A lot of detailed information is gathered by lightweight mechanism, and we offer this information to you for up to the last 35 days. So it's difficult to see this graph right here, but the y-axis on this graph is the CPU load, and the orange and the blue lines you see are SQL queries. So looking at this graph, you can quickly narrow down the areas where the performance bottlenecks are and review which SQL statements are actually causing all that bottleneck. So now you are quickly able to determine that, and you have the ability to act on that after that. This would be a free feature. It's going to get rolled out in phases throughout 2017, starting with the Postgres edition of Aurora. When we are designing an application, it's an application stack. We have to make sure that each layer or each tier in that application stack is highly available. Otherwise, the complete application will not be highly available. For example, if you design the application portion to be HA, but the database is not, you'll still see a downtime in case something bad happens with the database. So when we talk about high availability with RDS, we are talking about the ability for you to fail over in case something bad happens with your primary instance, or the ability for you to use another database instance in case something bad happens with the primary instance. So there are a few features that RDS offers for high availability. Let's look at them. Let's start with something simple. Let's say that you are launching a new RDS instance. You choose the region you want to work in. You choose the VPC where you want to deploy this RDS instance. In case you are using a single AZ configuration, you'll choose the availability zone point to the subnet where you want to launch it. And then you're able to launch your RDS instance in a single availability zone configuration. Now, this configuration is just fine if you're kicking the tires, you're testing things out, developing something, for example. But when it comes to running production databases, the best practice is to configure your RDS instance in a multi-AZ configuration. When you launch a new RDS instance in a multi-AZ configuration, or you modify an existing single AZ RDS instance into multi-AZ, what RDS does is it launches a standby replica of your primary instance in a different availability zone within the same region. And after launching it, it's going to synchronously replicate data between your primary node and your standby node. So this is synchronous, which means that any transactions are simultaneously provided to both the primary as well as the standby. One of the key features this multi-AZ configuration provides to you, it gives you higher durability, higher availability, but it also gives RDS the ability to provide to you automated failover. In case there is something wrong with the primary database instance, whether at the compute layer or at the storage layer, or the primary availability zone has any issues, or there is network connectivity issue to that primary AZ, RDS will automatically fail over to the standby and promote it to be the new master. To do this failover, which is automated, the CNAME record of your master instance, the DB endpoint, is flipped over to the standby, and then that standby is promoted. So this DNS failover typically takes anywhere from 30 seconds to 2 minutes to happen. One of the cool features is that all of this is automated. Since the endpoint itself does not change, you don't have to make any changes to your applications. As soon as the standby is promoted, it can keep using the database just like it was using. Another related concept is that of high availability. In case your primary database has performance issues because there are a lot of reads and writes happening, to scale the read capability of you can actually do two things. One is you can just scale up your primary database. You just get a bigger RDS instance. But you can also scale out the read capability of your database by launching more read replicas. And then the read portions of your applications can point to these read replicas, and the master is offloaded with the work of just doing read transactions. So it helps you scale the performance of your database. With the MySQL, MariaDB, Postgres, and Aurora database engines, you can launch these read replicas within the region or across regions as well. Now, if you're launching across regions, that gives you a couple of cool capabilities. The first is that if you have a globally distributed application, if your reads are local or closer to where your application is sitting, the performance is going to be better. And the other cool feature is that it's a good tool for you to have when you're designing disaster recovery type solutions, because these read replicas can also be used to fail over and become a master as well. You can get masters out of these. Aurora is designed differently. So I'm going to spend a couple of minutes talking about how HA works with Aurora. Aurora uses decoupling and service-oriented architecture techniques to break out database functionality into different smaller services. Logging and storage in Aurora is a different service. Caching is another service. I'm not going to get into caching right here. I'm going to just talk about the storage tier here. Within Aurora, storage is handled by 6 different storage nodes. These 6 different storage nodes are across 3 different availability zones in a region. So you get a lot more durability and availability this way. And these 6 different storage nodes are on a peer-to-peer gossip network, and they talk to each other to come up to speed. And they use a quorum system. If 4 of these 6 storage nodes says that they acknowledge a write, then the write is committed. So this makes Aurora performance very fast. Another cool feature here is that these storage nodes continuously and incrementally back up your data to S3. And S3, as we know, is designed for 11 nines of durability. The key thing here is continuously and incrementally. You don't have to schedule. You don't have to schedule these backups at all. And at the database tier within Aurora, you can spin up to 15 different read replicas. These 15 different read replicas can be in different availability zones. In this example, I'm showing 3 AZs. One is the primary node or the master node, and then we have 2 different read replicas. The cool thing about these read replicas is that they offload read load from your database, just like in other RDS database engines. But these read replicas are also failover targets. One of these read replicas can be promoted to be the master, or any of these can be promoted to be the master in case something bad happens with the master node. Now, which one is going to get promoted depends on the priority you assign. And these read replicas can be of different sizes. These can be different size instances, so you can choose if my master running in AZ A goes down, promote my read replica sitting in AZ3, which is the same size to be the new master. So, and this failover is quite fast as well. With that, I'm going to hand it over to Scott, and I'll be back to, at the end to conclude this presentation.
Great, thank you. So scaling your database to keep up with demand is an important part of operating your overall application or your workload. And if you recall on one of the earlier slides, I talked about one of the key value props of RDS is the ability to actually be able to scale up and scale down actually quite easily. So we're going to dive a little bit deeper into what are some of the things you can do around scaling when it comes to RDS. So why would we scale? Why do people want to scale? First natural one is just being able to handle changes in load over time, being able to handle higher load or even lower load to ensure that you're able to provide the proper level of service to your internal or external customers and also be able to control costs. You want to be able to just naturally grow over time. Maybe you want to launch a database to support an application that you're having in beta, and then you gradually roll it out to more users, whether it be internal or external. And that's going to naturally drive more usage on your database, and you're going to want to grow it up. But maybe you don't want to provision and pay for the largest database you think you'll need right at the very start. And then another note on controlling costs. All of this has kind of is supporting your users and controlling costs aspect to it. But what if you could actually have the ability to, if you have a database, let's say it's very heavily used Monday through Friday, and on the weekends it's hardly ever used at all. It's way over provisioned for the weekends. Another interesting idea around controlling costs when it comes to scaling is what if I could actually take my database and scale it down Friday night to a minimum size that's appropriate for the weekend. So the database is still up and it can be accessed if needed, but I'm not having to pay for this way over provisioned database during the weekend. And then I could scale it up Monday morning before everybody comes in and have the database up and running at the size that's necessary for the weekday. And I've been able to kind of use the scaling process to actually help control my costs a little bit while still being able to provide the right level of service to my end users. So when you're on RDS, there's a few different things that you can scale. One is the master database instance itself. And you can scale that vertically. You can make it bigger or smaller, changing the amount of CPU and memory that you're using for that database. You can also scale your read replicas. You can, once again, scale them vertically to get them bigger or smaller, but you can also do some horizontal scaling with your read replicas. You can actually add more read replicas to work with your master database if you need to, if you're getting a lot of demand on your read replicas. You can also do some scaling with the storage that's provided on RDS. Now, the thing to keep in mind, there's not as much flexibility that comes with the storage scaling as you might see with the read replicas of the database instance. And it takes time. You can actually provision a certain amount of storage on RDS for all the non-Aurora engines, and then watch that, and you can scale and add more storage over time to your database, so you're only paying for what you need as you need it. But that process can take up to 24 hours for the RDS service to actually get the new amount of storage provisioned, and you may see a little bit of performance impact on your database while that's happening. You can also scale up and down the IOPS that you have provisioned to your database if you're using provisioned IOPS storage. But once again, that requires a little thought and planning around when you'd want to do it, and it takes time for the RDS service to actually implement that and get it to the levels that you need. So it can be done, but you need to have a little bit more planning and patience when it comes to scaling around the storage. Katie mentioned a few minutes ago about the read replicas that Aurora offers. And in the last couple months, Aurora's released a very cool feature called read replica endpoints. So prior to this, with each read replica that you created in Aurora, you would have a separate endpoint for all of those read replicas. So if you had 15 read replicas as part of your cluster, you'd have 15 different endpoints that you need to manage and make sure that you're getting out to the right people and know who has access to those endpoints. So with read replica endpoints, With your Aurora cluster now, you get one read-only endpoint that covers all of your read replicas. So if you have one read replica, you have 15, it's the same endpoint. If you've used elastic load balancing in EC2, it's a very similar concept. So now you have the ability to scale your read replicas to meet demand, scale them vertically or horizontally, while never having to worry about dishing out or reclaiming endpoints from end users or applications who are using your read replica for your database. Scaling's got just a few steps that go with it, and we're going to focus on the master database instance in this case, but this is just some screenshots from the management console. If you're going to make a sizing change to your database, go to the instance actions options, choose the modify option, choose the new database instance size that you want. And then at the very bottom of the screen, there's this apply immediately checkbox. If you don't check that, the RDS service will do the modification, but it will do it during your scheduled maintenance window that you've defined for your RDS instance. I've missed this before, and I've sat there watching, waiting for it to switch to modify, and it never does. If you want that change to happen right away, make sure you're checking that apply immediately option, and the RDS service will start the modifications as soon as you commit this change. So we talk about scaling. Let's walk through what happens when you're running a single availability zone or a multi-availability zone configuration. So if you're running a single availability zone and you decide that you want to resize your master database instance, you've done all the work, you've checked apply immediately, the RDS service is actually going to take the existing database out of service and then resize it. And during that period of time, you will not be able to use the DNS endpoint that comes with your RDS instance to be able to connect to your master database. It will not be accessible again until the RDS service has completed resizing your database and bringing it back online. This is a screenshot of an example of the events that the RDS service sends during that period of time. You can see there's about a 3 to 6 minute window where my database was unavailable and inaccessible to me during that scaling operation. So that may be acceptable depending on your situation, but if you've got something that needs to be available a little bit more, that may not be suitable for you. If you're running in the multi-availability zone configuration, some cool stuff happens when you decide to resize your database instance. The RDS service is first going to actually go work on that standby database. It's not going to touch the master database yet. So you're, at this point, still able to receive connections and people can access your database. It'll resize that standby database, and it will then flip that standby database to be your master database, and it will repoint the DNS records to point to your new resized master database. And at that point, it will then resize what was the master database to match the size that you've chosen and turn that master database into the standby database. So you're still running in that multi-AZ configuration, and you're sized at the level that you need to be for both your master and your standby. These are the events that RDS records and sends when you're scaling or resizing a multi-AZ database. And you can see here that it's been doing a bunch of work before it even actually goes and does the multi-AZ failover. So in total, with just this DNS failover, you've got about a 30 to 60 second window where your DNS entries may be cached before they recycle. So your applications are going to need to be a little bit tolerant, need to either fail gracefully or retry those transactions during that short window when your DNS failover is happening. So now that we've figured out, okay, there are ways that we can scale different things on RDS, we can start thinking about what we can do around maybe automation for some of that scaling. So the top example here is just an example of using the command line interface for RDS, calling the modify DB instance command action. I'm setting the DB instance class to what I want it to be, and I'm setting the apply immediately option as a parameter into that command line call. Now, if you remember back to my example a few slides ago where I talked about being able to resize my database based on a schedule, based on usage patterns that I'm seeing where I'm very heavily used on the weekends or weekdays and hardly used at all on the weekends. We can actually now start looking at taking that, that CLI example, or if you use the SDK, that's fine as well. In my example, I put those into two different scripts The scripts are the same. The only thing that's different between the two scripts is the size of the database instance. So I've got a simple cron job that runs at 8 o'clock on Friday to call a script to scale down my RDS instance. And I've got a script another cron job that runs at 4 o'clock in the morning on Monday to scale my RDS instance back up to the size that's needed to support my weekday operations. And now I have some automated scaling happen around my database to allow me to be able to control costs in more of a hands-off way. You can even take that a step further for scheduling using AWS Lambda, which is our event-driven service. Lambda gives you the ability to actually schedule your Lambda functions so that they run very similar to cron at a particular period of time. So in this example, I've written some small Python code to, once again, call the modify DB instance API, give it a specific instance that I want to change, which size I want it to be, and set the apply immediately again. And then I scheduled that in AWS Lambda to run at 8 o'clock on Friday and 4 a.m. on Monday. Two different, basically the same script. The only thing that changes is the size of the DB instance. And I now don't even need a server to support running cron to be able to have my automated scaling happen. Going even further than scheduling my scaling, I can actually now start looking at using metrics that RDS makes available to me to do some more metrics-based scaling. So as Katie mentioned earlier, RDS sends many metrics into CloudWatch. You can create alarms in CloudWatch based on thresholds. When those alarms are breached, you can send the notification about that alarm to the AWS Simple Notification Service to a particular topic. And then, that topic, you can subscribe various things. I can have it send an email. I can have it call an HTTPS service. But you can also subscribe a Lambda function to an SNS topic. And what that gives me the ability to do now is actually be able to take action based on the alerts that are coming off of my metrics for the RDS service. So this is another example. It's an extension of the Python code I showed you earlier. This has been set up to actually pull the information out of an SNS notification that's coming from CloudWatch, pull out the name of the database instance, and then modify that database instance to a different size. Now, this is a very simple example. If you were using this for production, you'd obviously add in the things that matter to you, and you might also do some stuff around figuring out what's the current database instance size, and then choosing to step it up one if you're resizing, or maybe putting a block that says I'm not going to resize past this so that we can actually maybe dig a bit deeper. And this, we've been talking about the database master instance, but this same approach can be applied to storage layer based on the metrics you're getting off of the storage layer, or to your read replicas based on the metrics you're getting on your read replicas. You can use all of this to be able to do vertical scaling or horizontal scaling for your read replicas as well. So a lot of cool things that exist when it comes to building more automation around scaling of your RDS instances. And with that, I will hand it back over to Katie.
Thank you, Scott. Ability to take reliable backups to deal with issues like data corruption, disaster recovery, and to create other database instances is an important part of running and managing any database. So let's dive deeper into this topic. Let's start with automated backups. Automated backups are scheduled one time a day, and these are managed by the RDS service itself. You can specify the preferred backup window, and during that preferred backup window, the whole RDS instance, the whole instance is backed up. These are, by default, the retention period for an automated backup is 1 day, but you can configure it to be up to 35 days to meet your needs. The way it's done in MySQL, Postgres, Maria, Oracle, and SQL Server is different than how it's done in Aurora. For Aurora, as I was mentioning earlier, Aurora is designed differently. You don't have to schedule backups. There is no preferred backup window at all. Backups in Aurora are automatic. They are continuous, and they are incremental, and they are in S3. So it's much more easy to deal with backups in Aurora. Let's look at what steps are followed when automated backups happen. Now, this is for all the engines except Aurora. So every day during your backup window, the storage volume in your RDS instance is backed up. And if you're using a multi-AZ configuration, the backup is taken from the standby instance so that the performance is not impacted. Along with the storage instance, to restore your database, you also need the transaction logs. So 5 minutes of transaction logs are also backed up. The storage volume backup time along with the transaction log time give you the latest restorable time for your RDS instance. And you have the ability to restore your database to any second you choose within that restorable time. Show of hands, how many of you have had to restore a database? I see some unlucky people here. How many of you found it to be a pleasant experience? Oh, wow, we have some brave people also. Well, it's not fun. But RDS makes it much more convenient for you to restore from your backups. You just have to point it to from within the latest restorable period, you point it to the last point in time where you want to restore to. And restoring your RDS instance is similar to creating a new instance in the sense that you have to do some of the same configuration like you would do if you were launching a new instance. An important best practice from this particular feature is that you can actually restore to a smaller instance, which is very useful if you're just testing your backups. We should all test our backups. As we have seen earlier in the year, some bad things happen when the DR strategy is not tested, even within big companies. So when you're just restoring for testing purposes, use a smaller instance. When you are restoring from a backup just to give that RDS instance to a dev team, for working with it, you can restore to a smaller instance. But if you are restoring to replace your production database instance, then you will probably restore to a similar size and similar configuration like your primary database instance that you have. Another option for you is to use snapshots. Snapshots are manual in nature. You can take snapshots at any given time. And they are backed up to S3. You can also restore from snapshots and create new instances as well. One of the key features here is that you have more flexibility into how much the duration of retention. The retention period is not limited to 35 days, and you can keep them beyond 35 days as well. And the last topic I want to talk about is migrating to AWS. There are several tools and services that AWS provides, AWS partners provide, and there are a lot of cool tools in the open source community as well that make it easy for you to migrate to RDS. I'll give you a couple of examples and talk about two of the services Amazon offers. The first example I want to talk about is migrating from MySQL, which is running on-prem in this case, and migrating from that into a target Amazon Aurora instance within the RDS family. In this case, you can use MySQL dump. This is MySQL we're talking about, so the utilities work. RDS is no different. And use the MySQL dump facility to dump and then import the data in. But some studies claim that if you use Percona Extra Backup, which is a free open source tool, they found it to be 20 times faster. It's hot backup of your database. There is compression built in, and it's incremental. So if you use the Percona Extra Backup tool to create a backup file of your database, you can then bring that file over the wire into S3. You can speed that transfer up by using the transfer acceleration feature within S3. And you can also use multi-part uploads, which will chunk up your file and try to upload those parts in parallel and then stitch them back in within S3. That's also helpful if you have a file which is more than 5 terabyte in size, because that's the object size in S3. But if you're dealing with large backup files, say several terabytes, then you can also consider the AWS import-export Snowball appliance. You put your data in Snowball, ship it to us, we'll bring that data into S3. Now, once the data is in S3, creating a Aurora cluster from it is just a click away. You point it to the S3 bucket where that data is sitting, and Aurora cluster is generated from that. So it makes the migration path quite easy. The other example I want to talk about is SQL Server database migration. into RDS. And in this case, we are going to use the native backup restore functionality within SQL Server. That functionality gives you .back files. You again bring those .back files into S3 using Snowball or using multi-part upload, transfer acceleration, the whole thing. And once it is in S3, from the command prompt, you can just bring that data into SQL Server. A cool thing here, if you notice, is that the arrows are bidirectional. So you can use this method to migrate data into or out of the cloud. AWS Database Migration Service was announced at reInvent last year, made GA March of this year, and since that time it has done more than 14,000 different database migrations. One of the cool features of this migration service is that it supports heterogeneous targets. For example, you can migrate from Oracle to PostgreSQL engine of RDS, or you can have homogeneous MySQL to MySQL as well. When you set up database migration service, it's going to, you point to your source database, to your target database, and it does the work of migration for you. And after that migration is done, it keeps the two databases in sync so that you can choose the appropriate cutover time to move over to your target database. When we are dealing with heterogeneous migrations, such that your database engine in the source is different than database engine at the target, the database objects do not translate directly. I'm talking about stored procedures, schemas, tables, indexes, DML, constructs, etc. They need to be converted from one engine to another. AWS schema conversion tool helps with that. It's a development environment. You download it to your desktop, and you point it to the schema, and it's going to help you convert it to the target schema. It's not going to be 100% successful all the time, but for the portions in the schema it's not able to convert, it's going to highlight them, and it's going to give you suggestions on how you might migrate it. So it helps you reduce the overall time it takes to do your migrations as well. So with that, I would like to thank you for your time, and Scott and I would be happy to answer any questions you might have.